I told you that the students who usually do best in organic chemistry aren't the ones who memorize the most. Instead, it's the students who get to know the material, who spend enough time with the material that it starts to make sense. And those are two very different things. Hey there, ninjas. One of the biggest mistakes I've seen students make before they ever take organic chemistry is deciding what kind of class they think it's going to be. Many students assume it's going to be a memorization course. They imagine hundreds of structures, lists of reactions, pages of mechanisms, and they think the path to success is stuffing that all into their brain for the exam. But that's not how experts learn organic chemistry. And that's not how you, fellow OChemNinja, are going to learn it either. Take a moment with me. I want you to think about your favorite movie, or maybe your favorite series, or fictional universe, or game. Something you've spent years revisiting. You know the characters, you know their personalities, you know their motivations. Sometimes you can predict what they're going to say before they say it. For my generation, it was Seinfeld. There are still moments where I'll immediately think, I know exactly what Kramer would do. Maybe for you, it's Marvel, or The Office, or Star Wars, or Harry Potter. I bet there are times when you know what Hermione would say. But think about it for a second. It's not because you sat down with the script and memorized the script. You didn't highlight key quotes. You didn't make flashcards. No, you know them because you've spent time with them. You've encountered them over and over again. At some point, they stopped becoming information, and they started to become familiar. And familiarity creates intuition. You don't think, you just know. That's exactly what this character would do. And organic chemistry works the same way. Students often imagine that chemists have this magnificent mental filing cabinet. A reagent comes up, we open drawer number 742, pull out the correct reaction, problem solved. But that's not really what happens. Experienced chemists look at molecules the same way that longtime fans look at familiar characters. We can see certain patterns. We recognize tendencies. And we can predict certain behaviors. A carbonyl has certain habits. Carbocations follow certain patterns. A nucleophile has predictable behaviors. And an alkene has recognizable tendencies. You don't memorize every situation. You get to know the characters. And once you spend enough time getting to know the characters, many of the stories we tell become predictable. Now, imagine, someone said they wanted to become an expert on Seinfeld. And then they sat down and they read the script for every episode one time. Would that work? Of course not. The first experience is just an introduction. That real familiarity comes from repeated exposure. You watch it again. You notice things that you missed. You start recognizing themes. You start understanding motivation. You start making connections. And then eventually, the world makes sense. Organic chemistry works exactly the same way. You don't read chapter 9 and become an expert. You don't watch one lecture and suddenly own the material. You don't solve one practice problem and master mechanisms. No, you visit ideas repeatedly, and each pass reveals something new. And every path strengthens intuition. The big payoff to this approach comes at the end of the semester. You'll come across a reaction you have never seen before. And strangely enough, you'll have some ideas. Not because you've memorized it, you've never seen it before, but because you've met these characters before. You'll look at something like an acid and say, I know things about acids. You'll say, I bet that acid could protonate that oxygen. And then you'll say, I know things about carbonyls. Carbonyls are electrophiles. And I know things about alkenes. Alkenes are nucleophiles. I bet nucleophiles could attack electrophiles. And then you'll get excited and say, I've seen carbocations before. Nucleophiles can attack carbocations. And then all of a sudden, you're one proton transfer away from solving a mechanism you had no idea what was going to happen when you started. You'll start seeing the possibilities before anyone teaches you the exact mechanism. That's what intuition feels like. And this kind of intuition comes from familiarity, not from memorization. So, as this semester begins, here's my advice. Be a ninja, not a student. Don't treat organic chemistry like it's a vocabulary list. Don't treat it as a giant set of flashcards. Don't approach every chapter as something you have to memorize to survive. Instead, learn the characters. Get to know carbonyls. Get to know alkenes. Get to know alcohols. Get to know nucleophiles and electrophiles and curved arrows. Spend enough time with them that their behavior feels natural. Sure, the first time you meet them, they'll seem confusing. The 10th time, they'll feel familiar. The 100th time, you'll wonder why they ever felt difficult. And that's how expertise develops. Not through a single heroic study session, but through those repeated encounters. What I hope happens this semester is that organic chemistry stops feeling like a bunch of random reactions. I hope it starts to feel like a world with its own language and its own personalities. A world with its own logic that is predictable. Because once you understand the personalities of the characters involved, arrow-pushing mechanisms stop looking random. They start feeling inevitable. So before the semester begins, don't ask yourself, how am I going to memorize all this information? Instead, ask yourself, how well can I learn the characters? That's a much better question. And that's how people actually get good at organic chemistry. I'll see you in class, ninjas.
Thanks for watching. The best way you can support this channel is to let your friends know about these videos, especially ones who go to different schools. Help spread the word around the country. As always, don't forget to like and subscribe.